I'll try to give a broad overview of the different tools. I will broadly speak about large language model, LLMs, and generative AI, but we will see how we could use this new tool into the MEG and EEG analysis. So as you have seen during this very nice week, we have very well established toolboxes that are coming with lots of comprehensive functionality, batteries included. You could do incredible stuff. It's very powerful and delicate to manipulate, and still the reproducibility crisis is still going on. There are lots of papers published that are impossible or very hard to reproduce. Some results are very strange, and while the LLMs and Gen AI are a tool that are now very ubiquitous, and you have I think all of you have already used ChatGPT or different tools like that. Still, there is a lot of criticism. So we will try to see what are the different upcomings to consider here. We have set up a website, so you have a QR code here that you could flash, and everybody could vote and could ask question and upvote questions. So like that, it will be much more easier to discuss later on. So oh, sorry, I'll leave it a little bit more. So what I will do in this presentation is I will so briefly address the challenges you are facing and we are facing all today. That is, everybody is using the LLMs, and how could we use them responsibly? And there are too many papers to read. The technical complexity is growing also, and it's more and more possible to do pluridisciplinary research, which is very good news, but also very hard to handle. So to address all of these questions, I propose to follow a simple path, like a running example, where we will consider a pipeline, signal processing pipeline for EEG. So I'm coming from EEG, so I know more about EEG, BCI, so brain-computer interfaces. So here I will consider a simple motor imagery task. So a subject imagining clenching his right hand or his left hand, and using EEG recording, I want to classify those different signals, and if possible in some online manner, or at least to have a good idea on how does this work. So here at Practical Meg, I heard about some method like Riemannian geometry. I want to know what is the deal with this Riemannian geometry, how could it be used in pipelines, and so on. So I will take this example throughout all the presentation, and the idea is maybe to present next year a poster using this new tool, and how could I use AI for that. So just a very simple reminder or simple information about BCI EEG, where we are using mostly spatial filters or Riemannian geometry to make some classification, so online, as you see here. So the first step of the journey is to know what to read and how it's possible to monitor correctly and to focus on the review of the literature. This is a very, very difficult task, as there is roughly 1,000 papers per year on your topic that is really important, and on your specific topic, I mean, because I took down some number from Dimension AI. So if we look at the past publication mentioning EEG or MEG, we are roughly between 500,000 and for the and 75,000 for the EEG publication each year since 2019. And for MEG, it's between 20,000 to 30,000 paper per year since 2019 also. So it's really impressive, and it's very impossible to keep track of all those papers. So the question is, how could you try to find a way to look at what is the trade-off? So I know spatial filtering technique that is common spatial patterns, and I want to know what's in the literature about Riemannian geometry and how those two methods compare. So a first thing that I could do is to use Elicit. So Elicit is quite nice. You're discussing with this tool using your natural language, and the idea is to generate a report. So here on the right part, I could show you here. You could ask for a very specific either a research report or having a systematic review, or if you want to find certain type of paper, it's very easy to ask this to Elicit. And using the query that is compare common spatial patterns versus Riemannian geometry for motor imagery-based BCI, Elicit found 50 papers, and okay, it's loaded now. So this is something I generated some hours ago. So he extracted 50 papers. From these 50 papers, 10 were screened and read. There is a nice table summarizing the data set used, the different method compared, if he retrieved the full text or just use the abstract or the information. And like a small research report, you have an indication on what is the difference between those two approach based on these 10 paper. From my previous experience, Elicit is quite robust and gives a good view or select good paper on topics I know. So it's a very interesting tool. Indeed, you could save the report as a PDF. You could export the BibTeX file or the bibliographic file. So it's very easy to embed afterwards. But that's not the only tools available. So there are many other. One that is quite interesting is Semantic Scholar. So this one was introduced before Elicit and is based on a very specific algorithm to detect influential paper. So this very specific algorithm is able to extract citation graph. So to have a broad overview of a wide variety of paper, it's very interesting. And this tool is especially useful for curating a little bit. So you could only get good paper and or at least paper that are highly influential, or it's very easy to do that. So here I took one paper here, and you see is able to see who is citing this paper, what are the work that are coming after that are influenced by this paper, and what are the work that are highly influential. So it's a quite nice tool. Another one that is more graphical is the connected papers. So this one is quite impressive. It is able to extract lots of data from the journal and the publication to generate graph, and you could navigate in those graphs. see the different kind of information. You could ask to have mind map or stuff like that. And it's also possible to tailor the different plots. So I'm working with a brilliant PhD student, Bruno Aristimunia, and he made very nice graph of citation and showing that describe how each paper is influential for the follow-up work. So it's really it's really a tool that you could use very easily, and it's possible to take a dive to see what are the most paper, to open new graph from a paper that you found interesting and so on. So this is the connected paper. The last tool I'll speak about are research rabbits. So the idea here is to find your rabbit hole and to dig into paper you like. The other one is consensus. So here I have this question. What is the better approach between using covariance matrices for Riemannian geometry and CSP filter? In that case, I ask, are CSP better than Riemannian geometry for motor imagery? And this consensus website extract the different paper and try to answer a simple yes/no question using the information extracted from the paper. So here there are like 6 papers that are saying that Riemannian geometry is better than common spatial pattern for their data set, and for other it could be less clear. So this is also a way to quickly probe the scientific literature when you have lots of work to read. So I think now we have a quite good view on all the different parts you could see. One thing that is gaining a lot of momentum is the Notebook LM. So Notebook LM is a Google product that is used to generate audio podcast, you could say, or video, simple slides, just text slide with audio that you could listen to summarize either just one paper or many paper. I know that lots of students are listening to their classes and their syllabus using this. So here I have prepared a small audio extract that we could hear now.
This is the brief on decentralized multi-hub conferences. Okay, so you know traditional academic conferences, right? Well, they kind of create 2 big headaches. First, there's the massive carbon footprint, mostly from all that long distance flying. And second, they often end up excluding folks from historically marginalized groups.
Thank you.
But there's this.
So you see here, there is someone that is explaining the paper. You could ask to have 2 person arguing and having a debate, debating a paper or several papers. You could generate mind maps or a wide variety of output. So it's very interesting. This is the tool. So as you could see, it's possible to have mind maps. You could generate audio. You could generate video abstract. So this one is also interesting to listen to paper. So something different. Okay. So I will now move to the part where knowing now which kind of technique I want to use. Still, okay. I heard that this method was better than this one from the literature, but I want to test it from myself. So to do that, I need to code, and the best way is to use all the toolboxes you have been trained on, and they are manifold and very deep, but sometimes you could spend time to translate code that is working in R into Python or MATLAB, or you just found the code you want to use, but it's in Julia, and you need to translate it. So there are lots of specific steps that are very difficult to get. And the idea here is to see how AI could help you here. So the first possibility that is now quite widely available is the GitHub Copilot. So GitHub is now part of Microsoft, and they are pushing this technology a lot. It's still free for academia. It gets decent performance. It reuses all the code that is already stored on GitHub. So if you are using Copilot, it uses certainly the code from your favorite toolbox. And a nice addition is that depending on your coding style, is learning from your coding style to propose you code that is also fitting what you want to describe. So the very basic things to use here is this Copilot. I want also to show you another tool that is a little bit more expert, but that comes with very two major points, in my opinion. So this is KiloCode. So KiloCode is an AI agent that is open source, free, that is model agnostic. So this KiloCode is basically a Visual Studio Code extension. Now it uses also, it supports also a different type of IDE. But what is very interesting here is you could switch to whatever model you want. So if you want to use ChatGPT, or if you want to use Sone, or whatever model you want, it's definitely possible. And this kind of next generation coding assistant and Copilot improved a lot, so is doing the same kind of approach now, is that you could ask for code explanation. So you could find a nice piece of code online, or coming back after this practical Meg, you will look at the code you did during this week, and maybe some part you don't remember. So it's possible to use code explanation to ask for a refresher or having some explanation. It's also possible to use it for debugging. It's more and more used for debugging. So you could just say, okay, try to fix this problem. It doesn't compile, and now most of the time it's working. So it's a nice addition. And one thing I will show you is that you could do prompt announcement. So prompt announcement is when you ask an LLM to announce the prompt that you are feeding to LLM. So it's really working well. And usually your LLMs are very more accurate after doing this kind of prompt announcements. Last part is if you are using agent like that, it's possible to ask for writing commit message, doing git push, git pull, run some code, launch some tests. So each time this agent asks you if it's possible to do it, so you still launch the command, but he writes everything for you. And for me, the two most important turnaround here are the multi-step reasoning and the model context protocol. So the first one is that it's possible to discuss with an LLM and say, okay, help me to set up this project. So he will do it. And from this, he will break your code into small tasks, small subtasks, and it will be able to launch another agent, maybe a different model, just to take care of the code, or maybe only a sub-part of the code. So that way you could use a smaller model and so on. So it's very nice. And the last very big change is the model context protocol. So it's like an API, but designed for LLMs, so they could talk over internet, and they could discuss with libraries, environments, talk with GitHub or with your Git repository, talk with your hard drive or your storage. What is the space left on your NAS, or where could you put your data? And that way, the LLM could make informed decision because it will be able to discuss with some kind of unified markup language. So this is the model context protocol. So what I will try is to show you how it works. So we'll see what, okay, maybe okay. Maybe it's better like that. So what I wanted to show you is that it's in VS Code. You could install this kilo code, and you could select your model. There are like plenty of them. For each one, what is quite interesting is they gave you the price of each token, and how much does it cost for each request, and you could maybe tinker a little bit the number of token you allow, the deepness of the thought the model could get, and so on. So if yeah, say I just we'll see if that works. Okay, that do not work. Okay. So I will ask here, so I will choose different agents. So you have architect to plan your implementation, code to write code, ask if you want to have information about some piece of code, debugging, orchestrator. So let's take the architect and just say, okay, I want to have a Python code that will download some BCI dataset online from a toolbox. And I want to compare the accuracy of my two pipeline, that is a spatial filter, CSP, common spatial patterns, and simple linear discriminant analysis. And I want to compare this with covariance estimation and using minimum distance to Riemannian mean. So before inputting this, I will just click on the announce prompt. So it will think for a few seconds. So during this time, okay, I will come back to my presentation. Oh, okay. So you see, the prompt is now really much more long, much more accurate, and give into great detail everything that will be that the agent should take into account. And what I found very nice here is you see, so I choose the quite expensive model, and you see here you have the price of the request. So here you want to know what are the file. So he's trying to see what are the file. I'll just have a README file without nothing inside. So now he's thinking, and he proposed some plan. So his plan is he need information like he detect that I'm using Python, that I have different environments. So he saw that I'm using Mamba instead of Conda, and he asked me what is the environment I want. He asked me how should I organize the code, and the different strategy that I could use to evaluate the pipeline. So to simplify the work, you could either answer as a text message or select one of those already prepared answer. So I will say, okay, I will use this environment, have a simple script, just one, and use a different structure to store the static plots and the results. So I'm giving that. And you see here the model. Here we see all the requests, and for each one, you see how much does it cost. So one thing that he just did is to create a plan. So he's creating a to-do list, and this to-do list, as you see, is filling everything for me. Is filling this big plan, so architecture, where he's detailing everything that he will want to do, how will he do it, and so on. And at one point, he will ask me again, what do I want to do? So let him work a little bit, and I could show you some other coding tool while he's researching. So Cursor AI is another very famous toolbox that is doing exactly this agent-based stuff. There are Tab9, Code Whisper that is very, very good for if you are using Amazon Web Services. OpenAI just released Codex that is like ChatGPT but for code. And Google push something that is called Jules that is nice, but okay, all of those different toolboxes, I think it's good to test them if you want. And one thing you should be very careful about is that a lot of them to gain users, they are saying, okay, right now the inference is free, so if you are using my toolbox, every inference you are doing is free, or you just pay around €2 or $2 a month, and you have an infinite amount of token and stuff like that. And the problem is that it's already have been verified quite some time that it's not a sustainable model, because using LLM is not cheap, and it's not possible to stay that way. So usually you end up in very bad situation, like when you have a critical work to do, the resources are not available, or that they downgrade the model without telling you, or they use some premium stage. So if you are a premium user, you have different priority to access the model. And right now, there is a big problem with Cursor AI that completely increase the cost of using the model. So lots of teams are migrating from Cursor AI to other, or at least considering how much does it cost. So yeah, here, if we see, okay, he's still working. So he progress in his to-do list. And at one point, he will ask me if we want to switch to the code agent, and we will see that afterwards. So if you don't want to use those big fancy AI agents, still using the copilot is very simple. You start writing some comments, and copilot completes the code. It's very good to reduce the time you could take for writing very basic code like plotting, standard analysis, or if you want to read from a file or write from a file. Now it's very, very clever the way that the code completion work. And so that leaves you the time to focus only on the code that matter really. And it's also interesting in terms of learning to code, because it shows you like nice code with already nice way of writing and programming. So it could be interesting. It's not, you could have your own way of writing code, but sometimes you get some insight that are nice. So what I'm presenting in the with the code kilocode is really this architect part where you have different agents that interact with each other. And one thing that is very nice, maybe we could see this here, is that here we have the number of tokens I've used and the maximum memory of this model. So this is a very big model. So uh, the fact is, yeah, here you could ask to switch model and to use smaller LLM. So that way, it will cost you less and it will use less energy. Yeah, energy. Less energy to make the same request. So if you are splitting your problem into smaller ones that are easier to tackle, that way you could use smaller model and it's cheaper and faster. So here, okay, is continuing. So let this go. Still, not everything is that nice. There are lots of silence error. So the code works, but you have bad results. It's also very common that the code that is producing is way too complicated to what you had in mind. So you just want some very simple stuff, and the code architect is like starting a new toolbox just for you. And it's sometimes it's very difficult to just have the code you want. And the problem is if this agent AI is outputting some very complicated code, you won't get involved or you will just skim through it. So in the end, it will be very hard to maintain. But if it's a simple code that you could read and you appropriate, it's really better. Also, those are designed to code computer programs, so not to do neuroscience. So lots of the time, they could take arbitrary decisions that are very harmful for your analysis. So you need to be very careful about the kind of solution you obtain. And there could be also like a copy-paste pitfall, because if you have complex requests, it could take some code from one toolbox or trying to combine things that don't work together. So here I may state the obvious for some of you, but what is very important is to always test your data and first test on very toy data that you know and verify that the output are correct. The other important thing is to have a visual verification. So we have so nice toolbox, so you could use them to see all the different processing steps to be sure that everything is okay. And if you are a little bit more on the computer science, you could write unit tests. So it really changes and improve a lot the quality of the code that your agent will be working. And mostly you could see the agent as an intern. So he's working, yeah, we could see where he is. So he's doing C, okay. So, oh, okay, see new changes. Yeah, okay. So it's nice. I think he finished. So I could see how it's now. Oh, so he finished. Okay, he finished everything. So now he could code. So I need to approve to proceed to the implementation. Okay. So this is very good. The idea is you need to check what he's doing. Like if you are working with an intern that come up with some solution, it's good to just see that everything fits and is correctly working. And one thing that Anne-Sophie was saying is that these are coding assistants. They are not neuroscientists, so they don't understand anything about EEG or meg physics. They are really not able to take correct decision for choose the appropriate analysis. You need to do that. They could propose, see what people use on average, but you need to decide. And same thing for the result interpretation. Um, One thing that occurs to me quite a few days ago is I was working on a project with some code, and at one point, the LLM say, "Oh, the results are crap, so I will throw your data that you download, and I will use some randomly generated data because the results are really better." And it's okay from his perspective because he just want to push some nice code that is correctly formatted and so on, and you ask to finish to have a plot with two accuracy to draw, and it just changed everything. So yeah, it's important to read what he says to you and to change the data and to really check what he's doing. So now that we have your experiment, we have the code, we could try to write a paper with that. So how to use it for a research paper. And there could be several blocks, writer, the fact that for non-native English speaker, it could be difficult. Also, answering a review or two is always painful. And it's the same thing for writing classes. So if we have time, we could speak about how to write classes. So a very simple guidelines are you could use your LLM to ask for a nice paper title. So if you don't know how you want to name your paper, maybe you could ask that the paper is inspired from your favorite singer or whatever. You could, yeah, it's definitely possible. Checking grammar, your style also, there is no problem to do that. It's also possible to use it to rephrase some part or to develop some part and to discuss with the famous reviewer too to draft a polite response. So this is the different way you could use your LLM. It's also very important to check when the LLM is suggesting citation. It seems very basic, but yeah, cite what you know, and if there is a new paper, okay, it could be interesting, but indeed, you need to be sure about what the LLM is doing. So a very simple example is I have this input sentence like we found that the CSP feature work better for raw signal on motor imagery. The accuracy was 78 and 78%, and I could ask the LLM to improve the academic clarity. So I will have a much more fancier way to interpret my result, but indeed the thing you need to do is to verify all the numerical values because LLMs don't have any problem to invent numbers. So if you don't have this kind of precision on your results, like he's saying you have 78.3%, verify that it's really the case in your data. And here, it's also possible that after a certain number of edits, the number are not good. So you need to check also that what he's saying is correct. Like he's saying this is a 15.2 improvement in terms of percentage point, but in fact it's 14.2. So that are very basic verification, but you should do them. And the same thing goes for all the interpretation that should definitely be that you should conduct. There is the hallucination problem. In fact, it's more a problem for quite some time, especially since we have the deep search and the retrieval augmented generation. So now LLMs are trained to output data that are coming from known bases. So the finding an LLM that cites some non-existing paper, it's really not so common. But what is very common is what we found in our paper also, like citing a paper and saying, in this paper, this author says that, and the paper, the author doesn't say that at all, or maybe say the opposite. And as the LLMs copy human, so they copy also their mistakes. So this is very important. Okay. Uh, is the Zoom still okay? Okay, okay, good. Here it's very important to use the LLM for discovery and not verification, and you must indeed check all the verification. So when you are looking at a publisher reacted quite quickly in 2023, most of them. And after some movement, now what is commonly allowed in Elsevier, Nature, Springer, is that you could use grammar, spelling, or clarity improvement with your LLM. It's really no problem. You don't even need to declare that you use a LLM to check the spelling. So for example, you could take a look at the policies and standards for using generative AI of Elsevier. It's more or less the same thing in the Springer and in the Nature. What you should declare is when you are using an LLM to describe your method or to do like a literature review. That way, it's important to declare. And what is for most of the journals strictly prohibited is to do image alteration and image generation. So you could not generate the figure of your plot, for example, with an LLM. It's obvious, but still. And you could not have an AI agent as a co-author. I elaborate a little bit afterwards, but several people have tried it. In terms of requirements, it's mandatory if you are using AI for specific usage to declare them in your methods. For big machine learning conference, it's quite the same. They ask you to document all the AI use if it's taken a noticeable part. And in any case, they ask you to take full responsibility of what you are writing. For IEEE, it's really the same thing. The author accountability is really also quite emphasized here. So why having like ChatGPT as an author is not possible? The main problem is that this AI agent, could not take responsibility for the scientific claims that are in the paper. And that already made some problem in the literature, in the scientific literature, when a famous mathematician put his cat in the author of a paper. And the journal rejected it because the cat could not be held responsible for the scientific claim in the paper. So, okay. And there is the same thing in the ethical violation. So the problem is that as it could not be held accountable, there is a problem. And for the conflict of interest, it's very difficult to know how he will answer. So that way, okay, that way it's complicated. So it's still possible to use AI for heavily rewrite paper, but it's really a gray area. Also, you could use AI generating hypothesis, paper claim to do so, or you could use your LLM to interpret the results. So you give a bunch of results and you say to your LLM, okay, summarize what you found in my data. Um, the current consensus is that you should be held responsible for all the content regarding on the tool, regardless of what kind of AI did you use. So to finish on this writing part, one bias and one thing that is still in the blind spot um, is the coverage gap. So lots of lots of the way the LLMs are trained made them very oriented toward English language. So that was one part of the reason that led Timnit Gebru, that was the ethics officer from Google, to be fired from Google because she said that LLMs were not good enough for non-English journal and non-English speaker, and that it was introducing bias toward the population that don't speak English. And there is the problem also that in all the tool I showed you, all the paywall journal are very, very strongly represented. So all the open science, open source journal are less visible. So that's also a concern. There is a recency bias. So LLMs are really, really much more focused on like a newer paper. So they could completely ignore uh, so older paper, and also paper that are too new are not part of the training. So they won't appear. And there is also a cultural bias that came from the scientific literature. And that, okay, we should be aware when we are using AI for scientific writing, especially in neuroscience. So um, there are some references there. Now that we see how we could find some nice paper, do some experiments, and write some paper. I think it's a good time to see how could we use AI responsibly. So the first thing is the reproducibility crisis. So there are two sides of this coin. First one is that LLM outputs are non-deterministic. Um, I prepared the experiment here, yeah, this one. So I just running really literally just before the presentation, and the output was something different. And here, maybe it's because I changed the size. No, okay. I don't know how I could approve and to switch to code mode. Um, like 5 minutes ago, it was very easy to click. So if I'm not presenting, I think I will find the solution. But what is very interesting is that as they are non-deterministic, it's very complicated to use them as a pipeline that you could launch and that will give you the same results each time. So replication could fail, and it's difficult. On the other side, I'm quite convinced that LLMs are good candidates. If we say something like, okay, take this paper, take this method section, and try to re-implement what's in the paper. And if your paper passed the test, it means that you are completely reproducible. And I think it's possible to generalize this quite a bit. So maybe as the output are not deterministic, there should be some threshold or relaunch several times. But if at least you could reproduce it once, I think it's good. What we should do more is to document and to write that those part of the code was generated with GitHub Copilot using that version, and the code for using the analysis or to test for synthetic data was done with this model of LLM. So it's very important to have this kind of criteria. One thing that is also like the big elephant in the room is the environmental cost. So a few days ago, the Shift project just released the AI and data center report, and that is taking a big picture of how it's going, and it's not good for the data center. So in terms of energy consumption, the energy consumption is really on the rise for the data center, so mostly for LLMs and computations. And what is quite problematic is that in Europe, we have seen two things. One thing is that there is definitely a rebound effect. So we have LLMs that are better to use less energy to make more accurate precision. So smaller LLMs that gave better output. And we have also better hardware. So the hardware is more efficient. But with this product being more available, we are using them more. So in the end, the electricity demand increases. And one concerning thing in Europe is that this increase is absolutely not factored into all the planning for the electricity consumption at the Europe level. So I just pick one picture from the Shift project. So they made a very abstract, very short summary that could be read very fastly. And what it shows is that this rebound effect. So we are able to supply better model, more of them, so people are using them more. So what we could do is we could reflect maybe a little bit more and take this into perspective. Another point that is very important is the peer review and all the review that you could be asked to do. So editors have absolutely no problem to let you write with AI. They have absolutely no problem to let you search your bibliography with AI, but really you should not use generative AI to do peer review. And albeit it's very tempting because sometimes we have lots of them to do in a short period, but there are really two main problems. The first one is a PI problem, IP problem, sorry. So in terms of IP, the conference or the journal is giving you a work that is not published and that is trusting you to be the sole person to read this paper and to comment on it. So if you put it in LLM, you don't control where it goes. So, okay, it's still possible to have a local instance of a LLM, and several institutes are using it in ICM in Paris. But still, there is a big problem here, is that if you are using an LLM to review a paper, it means that you are not really delving into the paper, and that no one will take responsibility for what is published. So at one point, there should be a human supervision. To give you a very simple parallel example, for the Montreal town, Microsoft proposed to use generative AI to make like tours. So you could take a tour of the city of Montreal and see nice place in Montreal. And nobody read what was written. And the AI spot that in front of the the place. I don't know how it's called, but it's a place where you give food for people who could not afford it. There was always long queue of people waiting to get something to eat. So the tour was saying, okay, you should go there in this particular alimentation bank. You could get nice food because there is always a big queue, and this is a nice place to see all the life in Toronto or in Montreal. And you should always read what is written. So it's very important to not take generative AI to do uh, to do this kind of reviewing. So it's the case for almost all major conferences, and journal as well. Another big concern is the paper mills and the scientific fraud. So Retraction Watch call it like trying to empty an overflowing bathtub using only a spoon. And you see the number of paper mill are really exploding because it's so easy to produce fake paper. And they are grammatically correct, perfect even. It seems quite nice, but if you don't know, if you don't really read them, they seems correct. So this is why we should not let any LLM read the paper. So the paper, there is a PNIS paper that is very, very nice about this. So this is very important to avoid using this for reviewing articles. Last, I think one of the last point I want to raise is the skill atrophy. So this is something we could hear a lot, like students that are using generative AI will not understand anything, so they can't debug, they won't know how it works, and so on. So the fact is, it was already a concern when we first used toolboxes. So okay, it seems not really a threat. What seems more like a threat for me is it's something that is already happening in IT departments. It's so much inexpensive to give credit for a few tokens to an expert or a senior person to do the work, because using an LLM, he could do the work of five juniors. But if you don't hire junior, you don't train them, and they need those very basic tasks that a senior, with the help of an LLM, could take like a dozen of them. But we need to train. We need to have like skill development opportunities. So for me, it's really more something we should be concerned about. And last thing, it's the vibe research. So it's still possible to uh, as it's possible to vibe code, so you don't touch your keyboard, you just discuss with your AI and say, okay, do this, do that, relaunch the experiment. You could write a paper like that, like propose some nice hypothesis. No, not this one, another one. Find a new hypothesis. It's possible to do that, and some paper claim to do it. It's very possible that the AI will use p-hacking to get significant results, and it will be very difficult to reproduce them. And certainly we will have confirmatory bias. So we really need to keep the science correctly.